solve one example of this right now. So hopefully this will be easy. This shouldn't take a week, but you have a week to submit. Yeah. Okay, let me stop presenting.
স্যার স্যার বইয়ের এটা
So,
কত নম্বর চ্যাপ্টার?
um, we're doing diodes, so it should be the first chapter. I mean, I'll check and confirm, but it should be the first chapter, diodes. First chapter, you'll find introduction to semiconductors, PN junction, and diodes, uses of diodes from the Neiman book. Hmm? So last class, where did we start? We solved a problem with diodes. We figured out how to find out equivalent. Yes, so we talked about piecewise linearization, right? Um, so let's see if I can do this. Okay, now that's not work at all. I need a stand. The stand that lay. It's mirrored.
So I think you can join in two different places.
I can join from my tab, but I cannot share the screen from there. So that is the problem. Mm, Let me join and try again. Share screen. Let's start podcast. Yeah, I think I figured it out. Thank you. Let's see. Okay. Yes, there you go. Acha. This is nice. Can you see my screen now? The whiteboard screen.
Yes, sir.
Perfect. Acha, so last class, we did piecewise linearization. So piecewise linearization. Hmm. What we did was we converted a diode into its equivalent resistance plus a voltage source, right? The voltage source was the breakdown voltage, not the breakdown voltage, it's the forward voltage, the forward voltage, and the resistance RD, it's the diode resistance. Diode resistance. And how did we do that? We started with a nonlinear curve of the diode. Nonlinear curve, we chose a point to find the slope at that point, right? The slope m equals 1 over rd, and you have v gamma, which is usually given or fixed. This is a fixed parameter for fixed for the type of semiconductor. So if it's silicon, you have a certain value. If it's germanium, you have a certain value, a different value for that. Okay. Or you can also find it from the graph by bringing that point here in the x-axis. So a straight line টা where it meets the x-axis, এই ভ্যালুটা হচ্ছে your v gamma. আচ্ছা, এখন যদি I give you this plot, I, which is v, 0, 1, 2, 3, this is 1, 1.5. So this point is, let's say this is A, this is B, this is C. তাহলে can you find the event RC circuit um, for the diode with the following the linear array the characteristics. আচ্ছা, can you try and solve this graph um, for a diode, a linear graph টা? So you what you do is imagine you have a diode here with these characteristics এবং the characteristics changes over two regions, right? So there's region A to C and region A to B. So আপনাকে you convert it to this V gamma and RD. So basically find RD and V gamma for two regions. You have AC and AB. Try and do this yourself. I'll give you 5 minutes or maybe 2 minutes. We already lost a lot of time. So try and see if you can figure out RD and V gamma for AC and AB regions.
So they will be separate expressions.
Yes, current they have different slopes, so the values would be different. You do it the same way. The procedure হচ্ছে same, কিন্তু value গুলা different হবে. If you have an answer, let me know what the answer is. So let's go ahead and solve this. So what we learned from last class is that the slope of the linear curve, slope equals m. The slope m equals 1 over r d, the resistance of the diode. And this is for AC. Huh? For AC, what is the slope? So slope, how do you find out the slope? So it's y1 minus y2 over x1 minus x2, right? তাহলে if we take A as a first point, তাহলে the value of y is 1 minus C. If it C is the second point, 1 minus 0 and 2 minus 1. That is A. আচ্ছা, let me write the points here তাহলে it's easy. A হচ্ছে 2 1, B is 3 1.5, C is 1 0. These are points on the graph. হ্যাঁ, তাহলে um, we have just one. So 1 over 1 is 1. তাহলে R D equals 1. আর V gamma কি হবে? What will be V gamma? The V gamma,
2 volt.
আচ্ছা, V gamma is the point where the diode starts conducting, right? যেখান থেকে zero থেকে conduction start হয়. That's your forward voltage. That's the minimum voltage required for current to flow through. So V gamma is this point where you have current flowing through the circuit. তাহলে V gamma is actually 1 volt. এটা হচ্ছে 1 ohm, 1 volt. So equivalent circuit এখানে হ্যাঁ R&D is um, these values. Now for AB, for AB part, what's my slope? M equals um, B হচ্ছে 3. So no, 1.5 minus 1 y values. হ্যাঁ, y values subtract করবো. First y1 minus y2, x1 minus x2. So the value of x at point B is 3 minus the value of x at point A is 2. That is 0.5 over 1. যেটা আর কি 0.5. Um, so এটা equals 1 over RD, right? তাহলে RD equals 2. So 1 over 0. Let me show you. It's 2. 2 ohms are for the region AB. AB এর জন্য now for AB, what is V gamma? Do you
2 volt.
do you bring this one back like this, or is it C, or is it 2? Look, in this graph, a current flowing did not start at 2 voltage, right?
So point 0.5.
No. So what we'll assume is that current started flowing at the same point. এরপরে এটার slope change হয়েছে, resistance changes. হ্যাঁ, কিন্তু এই current flowing কিন্তু it started here. হ্যাঁ, that doesn't change. So V gamma will still be the same value. আমরা যদি we can plot it backwards, কিন্তু we already have a value from the plot. আমরা plot থেকেই দেখতেছি exactly কোন পয়েন্টে the diode started conducting. So আমাদের এইটা করলে কি হবে? এটা হবে আরেকটা approximation. আমাদের approximation দরকার নাই. We already know this point. So এই forward voltageটা 1 ভোল্টই থাকবে. It will remain the same. এটা নিয়ে কারো কোনো কোয়েশ্চেন আছে?
স্যার ভিআর এর বিষয়টা আরেকবার বললে ভালো হয়।
এই ভি গামা যেটা ফরওয়ার্ড ভোল্টেজ এটা,
জি স্যার, ভি গামা।
আচ্ছা, আমার যেটা বলছিলাম যে আমাদের এই প্লটের ক্যারেক্টারিস্টিক্সটা চেঞ্জ হতে পারে। হ্যাঁ, আমাদের let's see, এরকম আমরা যখন লিনিয়ারাইজ করি তো আমাদের অ্যাকচুয়াল গ্রাফটা থাকে এরকম। তো এইখানে ডিফারেন্ট ডিফারেন্ট পয়েন্ট আমরা যখন নিব, দেখি ডিফারেন্ট ডিফারেন্ট পয়েন্টে আমাদের স্লোপটা কিন্তু ডিফারেন্ট হবে। এইখানের স্লোপটা এরকম, এইটা এরকম, এইটা হয়তো আরেকটু এরকম। তো এরকম যখন when we connect all these linear lines, লাইনগুলা অলমোস্ট দেখতে এই যে এটার মতো হবে। হ্যাঁ, এটার মতো হবে যখন আমরা we join these lines. কিন্তু the point where it starts conducting current, এই পয়েন্টটা কিন্তু ইটস অলরেডি নোন, যেখানে এই এক্স অ্যাক্সিস কে ক্রস করলো, দ্যাট পয়েন্ট ইউ অলরেডি হ্যাভ ফ্রম দ্য প্লট। সো আমাদেরকে এই প্রত্যেকটা পিস ওয়াইজ এস্টিমেশনের জন্য উই ডোন্ট হ্যাভ টু ফাইন্ড দ্য ভি গামা। এটা অলরেডি ইটস দ্যাট পয়েন্ট অন দ্য প্লট। আচ্ছা, ইটস দ্যাট পয়েন্ট হিয়ার অন দ্য প্লট যেখানে first the first line crosses the V axis, because that's the point that it starts conducting. There is also an approximation, by the way. হ্যাঁ, এটা কিন্তু এরকম একটা কার্ভ ছিল, কার্ভের অ্যাপ্রক্সিমেশন, বাট দিস ইজ দ্য মোস্ট the closest approximation you'll get. আপনি যদি if you plot from the other lines যেগুলো উপরে আছে, এই লাইনগুলো থেকে plot back করলে you'll get different values that are not as accurate as the first one. এই জন্য we take the first line, এবং ওইটা যেখানে ক্রস করবে ওইটাই হচ্ছে গিয়ে v gamma for the entire plot. হ্যাঁ,
বুঝতে পারছি স্যার।
আচ্ছা, now that is done. So এই কাজটাই, সেম কাজটা আপনাকে you'll have to do it in the homework again. Okay, so let's look at a couple of other models for the diode. Linear, we looked at linearization from graph. এটা ছিল linearization from graph. Now, if we don't have the graph, তখন কি করব? Then we have a constant voltage drop model. Constant voltage drop model. Constant voltage drop মডেলটা কি বলতেছে? For the constant voltage drop model, it assumes যে once it starts conducting, once the diode starts conducting, there is no resistance. The voltage drop, there is no resistance to the voltage drop. তাহলে কি হয়? If you don't have any resistance, তাহলে uh, আমরা জানি যে স্লোপ হচ্ছে 1/r, রাইট? দ্য স্লোপ m হচ্ছে 1/r। এটা যদি হয় 0, if rd equals 0, rd, তাহলে m হচ্ছে 1/0 ইনফিনিটি। So infinity হলে uh, that's the plot you get when you have infinity. This is m equals infinity. What does that mean? That means আমরা যদি প্লট করি ইকুইভ্যালেন্ট সার্কিট, হ্যাঁ, ডায়োড থেকে তো এটার ডায়োডের ইকুইভ্যালেন্ট সার্কিট ছিল আরডি আর ভি গামা। If RD is 0, then what are we left with? We are just left with the voltage, the V gamma, the forward voltage. তাহলে এই পয়েন্টটা হচ্ছে, this point is V gamma. এটা হচ্ছে VD ID. তাহলে এই মডেলটা হচ্ছে গ্রাফের থেকে লিনিয়ারাইজেশনের থেকে একটু ইজি, because you don't have to calculate VRD. You do not need a graph for the slope. You only need to know what the forward voltage or V gamma is. তাহলে and I said that it's fixed, constant at room temperature, temperature for the type of semiconductor used. It's fixed. So for silicon, we can assume it's 0.7 volts. For germanium, we can assume it's 0.3 volts. তাহলে আমাদের সার্কিট অ্যানালাইসিসটা আরো ইজি হয়ে গেল। Let's go back to that example from yesterday and solve that again. হ্যাঁ, আমাদের from last ক্লাসের এক্সাম্পলটাতে we had a circuit like this, right? যেখানে the resistance here was 10k. E here was 10 volts, and we had to find ID. আচ্ছা, তাহলে এখন এটার ইকুইভ্যালেন্ট সার্কিটটা কি হবে? You, for for the assumption that it's a constant voltage drop model, for a constant voltage drop model, the equivalent circuit is going to look like this, where you have E, R, and V gamma. So if the diode is made of silicon, you put 0.7 here for Si or zero point 0.3 here for germanium. That's it, and you have the rest of the values here the same. তাহলে current using mesh analysis, current কি হবে? Current would be 10 minus, let's say it's silicon 0.7 over just that, just that resistance. There is no more resistance. হ্যাঁ? এটা যা হয় সেটা হবে. So you see, our circuit analysis becomes much more easier with a constant voltage drop assumption, um, and our equivalent circuit becomes just a voltage source with no resistance. This is one model. We have another model for simplification or linearization of diodes. The second model is ideal diode model. What does the ideal diode model say? Ideal diode model assumes just what the name suggests, that it's ideal. So ideally, the diode should conduct electricity when it's forward biased, right? There should not be any um, minimum voltage requirement. So it assumes that V gamma is zero, RD is also zero. তাহলে with this assumption, what does this circuit become? A, what does this circuit become for ideal diode model? You have E and R. যেখানে কি হবে? There is no voltage and no resistance, so it's an open circuit. Hmm? It becomes an open circuit. There's nothing. So this ideal diode model is actually not very useful in most cases. Um, but this is something, yeah, you can assume. It's wherever you put a diode, it's an open circuit. Open circuit. Do we have time? আচ্ছা, Let me talk about one more thing. And any questions so far? Okay. So let's talk about the VP minus VN rule for diodes. And for this, we will assume the constant voltage drop model. Hmm? For this part, we'll assume the constant voltage drop model. Okay, let's say you have a diode and a resistor in series. This is a resistor, this is a silicon diode, and eta V1, um, V2. This is 5 volts, this is 2 volts. So you have two different potentials at two ends of a circuit with a diode and a resistor. এখন you have to sort of, let's say you have to solve this circuit. তাহলে first off, you need to know if the diode is forward biased or reverse biased. Hmm. So what the VP and VN rule says is that you can, or this is, yeah, this is to solve the circuits easily. So figure out what the positive and negative part of the diodes are. Polarity diode, remember, this is plus, this is minus. Look at the arrow. Positive side, say it's VP. Negative side, um, label it as VN. Uh, a polarity basically means it's right. It's grounded, right? This is ground. This is um, so এখানে একটা 2 ভোল্টের পাওয়ার সোর্স আছে, and you have let me do this nicely. So এখানে 5 volt, 2 volt. Oh, it's the same as drawing this. It's the same. হ্যাঁ, এখানে 5 volt and 2 volt. This is 5 volt. So you assume you have a VP on the positive side of the diode, VN on the negative side of the diode, and then just do VP, do VP minus VN. So in this case, VP is 5 volt, VN is 2 volt, so you have 3 volts. Once you have a value, তখন you'll have to um, consider is it forward biased or reverse biased. So obviously this is um, the siliconer V gamma is 0.7 volt, right? So this is more than 0.7 volt. 3 volt is more than 0.7 volt. So obviously this is forward biased and it conducts current. Into if we want to formalize it, মানে আমরা যদি সুন্দর করে এটাকে একটা ফর্মুলা আকারে লিখতে চাই, তাহলে we can write it like this: if vp minus vn is greater than v gamma. V gamma is a forward diode voltage. তাহলে কি হবে? তাহলে it's forward biased. The diode is forward biased অথবা it's on. Equivalent circuitটা কি হবে? Equivalent circuit would be a voltage source. Resistor তো already ছিল, right? So Vn, Vp, this is 0.7 volt, and this is the R that already was there. এটা হচ্ছে if Vp minus Vn is greater than V gamma. Now what if it's not? If Vp minus Vn is less than V gamma, তাহলে কি? The diode is reverse biased.
স্যার আরডি হবে না একটা?
Remember, this is the constant voltage drop model. And constant voltage drop model, we assumed কোথায়? এই যে constant voltage drop model, we assume that RD is 0. এই যে
আচ্ছা স্যার।
um, এই যে RD it's 0. হ্যাঁ? আচ্ছা, so it becomes reverse biased or off. আর constant voltage drop model reverse bias থাকলে কি হয়? আমরা মাত্র দেখলাম it becomes an open circuit. Vn, Vp, because there's no current flowing through it. So if there's no current flowing through it, it becomes an open circuit. ID 0. আচ্ছা, এইখানে তাহলে in that case ID not equals to 0 for the forward biased. Reverse biased RD equals 0. And there can be a third case. What's the third case? Vp minus Vn. What can it be? It can be equal to V gamma. Right? We have greater than, less than. The only other option is it can be equal. What happens if it's equal? Equal, well, we call it the diode is in transition state. Transition state. What happens in the transition state? Transition state, we still have a voltage for the diode model. Diode জন্য এই ভোল্টেজটা আছে, and this is V gamma, Vp, Vn. But because it's equal, এখানের Vp minus Vn এর যেটুক voltage আছে, it's equal to V gamma. Because Vp minus Vn is equal to V gamma, তার মানে কি এইখানে যতটুক potential difference ছিল, all of it um, is going into the diode, right? Diode forward bias করার জন্যই every the entire potential is being used. তাহলে কি হয়? There is actually no current flowing through it. So we do not get a current flow because it's equal. So anything after that, এরপর আমাদের এই ভিপি মাইনাস ভিএন যদি আর একটু বাড়ানো হয়, we get some current flow. কিন্তু when it's equal, there is no current flow, but we still have the entire voltage between these 2 points being dropped across V gamma. Any questions
Sir,
on this? Huh.
what about when there's diffusion, as you mentioned?
What do you mean when there's diffusion? When there's diffusion in the PN junction of the diode?
Yes.
আচ্ছা, first off, PN junction যখন create হয়, যখন when the diode is made, we already have a barrier. Diffusion হয় to create that barrier. এরপর যখন current conduct করে, there is very little amount of current generated by the diffusion itself. um, ওইটা you can ignore. হ্যাঁ, just remember যে ডিফিউশনটা হয় মোস্টলি, the majority of the diffusion is during the making of the diode. ডায়োডটা যখন বানানো হয়, when we connect the p and n junctions together, and when the breakdown region is being made. Once that's done, the majority of the diffusion is done. এরপর I talked about the the amount of the depletion region changing because of the current. Remember? তো এইখানে কি হয়, when the current flows in the positive direction, you a depletion regionটা কমতে থাকে, right? So at transition state, when it's equal, when the potential is equal to V gamma, তখন there it's like an equilibrium. There is no let's say আপনি যদি ফিজিক্সের কথা চিন্তা করেন, there is no depletion region, but there's like enough force to sort of get the depletion region to zero, but not enough to get a current flowing. হ্যাঁ, এর পরে ওই ফরওয়ার্ড ভোল্টেজের পরে if you put any more voltage in, তখন current starts flowing. So it's like an equilibrium at Vp minus Vn equals V gamma, ওইটা হচ্ছে equilibrium থাকে। তো I don't think you have to think about diffusion at that point. ঠিক আছে?
Yes, sir.
আচ্ছা, so এই জিনিসটা it looks pretty simple for now, তাই না? যে Vp minus Vn uh, greater than V gamma হলে it's um, forward bias, না হলে reverse bias. It looks pretty simple, কিন্তু remembering this will আচ্ছা, it it seems simple for simple circuits. হ্যাঁ, যখন এই এক্সাম্পলটা তো it's a simple circuit, it looks pretty simple, but when you have complex circuits, remembering this will help you a lot in solving circuits. Okay. আচ্ছা, আমরা যদি এই তিনটা কন্ডিশনকে গ্রাফে চিন্তা করতে চাই, let's draw the graph again. So IV characteristic constant voltage drop model কিন্তু এটা ছিল, R0, and you have some forward voltage, এটা VI, এটা হচ্ছে V gamma R0. So constant voltage model, when you have Vp minus Vn greater than V gamma, you're actually looking at this region. এটা হচ্ছে 1. When it's less than V gamma, then it's this region. Huh? So it's this region. And when it's equal, you're actually looking at this region of the graph. So these three conditions actually represent these three regions in the IV graph. Any questions on this? Let's solve a simple circuit. I think if we show an example, it might be easier for you to understand what's happening. Huh? One example, and then we will end the class for today. Mm, আচ্ছা, এইটা হচ্ছে V1 equals 5 volt, V2 equals 3 volt, R equals 2k ohm. This is silicon diode. We have to find V naught. Find I, find I and V naught. I'll give you 1 minute to think about it before I solve. We don't have enough time for me to let you solve it by yourself. Next class, we'll solve another problem and then I'll let you solve it yourself. But for now, think about um, how you're going to solve it. I'll give you 1 minute.
Sir,
Yes,
won't it be 4.3?
I.
V not?
V naught will be 4.3. Okay, that's one answer. Does everyone else agree with that? আর কারো কোনো অল্টারনেটিভ অ্যান্সার্স আছে? Okay, let's see. তাহলে এটাকে যদি আরেকটু ইজি করে লিখি, ইকুইভ্যালেন্ট একটা সার্কিট ড্র করি, you have 5 volt on one end. হ্যাঁ, 5 volt. Let's say this is 5 volt. And you have a diode here and a resistor. And on the other end, you have 3 volt. Hmm, 3 volt. This is R. And we are assuming current flows like this. এটা হচ্ছে I. So আমরা এই VP minus VN রুলের ফার্স্ট কাজটা কি করেছিলাম? We figured out the polarity of the diode. So এখানে ডায়োডের পোলারিটি কি? This is plus, this is minus, correct? এখানে যদি ড্র করি plus and minus. So if we have plus here, তাহলে this point is going to be VP. This point is going to be VN. Any questions up to this part? VP and VN determine করা নিয়ে কোনো কোয়েশ্চেন আছে নাকি কারো? Okay. Next কি করব? VP minus VN. We find out what VP minus VN is. তাহলে VP কত? 3. VN is what? 5. Then VP minus VN is -2, and -2 is what? Less than, এটা কিসের? এটা সিলিকনের, right? It's a silicon diode. So ওইটার forward voltage V gamma is 0.7. This is less than 0.7. তাহলে কি? What does that mean? Therefore, the diode is the diode is reverse biased. তাই না? আমার VP minus VN যদি less than the minimum required voltage হয়, then আমার এই ডায়োডটা it's in reverse biased. তার মানে the circuit is actually an open circuit. 3 volt, 5 volt, and we have an open circuit here. Into V naught. তাহলে ওপেন সার্কিটে কারেন্ট কি থাকে? What is the value of I? We wanted to find I. I is 0. There is no current in the circuit. Voltage কি হবে?
3 volt.
ভোল্টেজটা এইখানে মেজার করা মানে কি? It's the same as connecting one point here and another point, let's say here in the ground, right? Since there is no current, so there is no voltage drop. No voltage drop across this part. তাহলে yeah, it's 3 um, oops, 3 volt. কারো কোনো কোয়েশ্চেন আছে? আচ্ছা, if not, we will stop here. আমাদের নেক্সট ক্লাস হবে নেক্সট স্যাটারডেতে। থার্সডে ইজ অফ। কারো কোনো কোয়েশ্চেন থাকলে অথবা হোমওয়ার্ক নিয়ে কোনো কোয়েশ্চেন থাকলে রিচ আউট টু মি, I'll be happy to help. আর আমি I'll upload this lecture in classroom. Or do you need the uploaded version? Because someone was telling me that he'll be recording the presentation anyways. So just recording থাকলে হবে নাকি do you need a copy of the lecture as well?
কপিটা হলে স্যার ভালো হয়।
আচ্ছা ঠিক আছে, আমি আমি এই কপিটাও দিব and then you can have the video as well. Let's take the attendance and then we'll go. Mm. সাদমান রহমান,
প্রেজেন্ট স্যার।
আবুল হোসেন, শাহ ইসরার মির্জা,
প্রেজেন্ট স্যার।
নিশাত মেজামিন।
Present, sir.
Acha, let me do something. Let me share my screen so you know who's coming up next. Said Ishaqur Rahman, Tasnimul Hassan, Israt Jahan,
Present, sir.
Rafsan Wazed, দেবারতী সরকার,
Yes, sir.
আকিব,
Present, sir.
আহমেদ নাফিস,
Present, sir.
সাইফুল্লাহ, মন্তাজুল হাসান, নেওয়াজ ইশরাক,
Yes, sir.
তাসিন আইমান, রাইসা আঞ্জুম,
Present, sir.
অরিক আনজাম, সাদ মাহমুদ,
Yes, sir.
প্রিয়াঙ্কা রয়, খান প্রিয়াঙ্কা রয়,
Present, sir.
আচ্ছা খান মোহাম্মদ প্রেজেন্ট রাইট,
Yes, sir.
ফাবিহা, হাফিজ উদ্দিন,
Present, sir.
সালমান বিন সারওয়ার,
Present, sir.
অভিজিৎ কর্মকার, মঞ্জুরুল করিম,
Present, sir.
সাদমান ইর্তিজা,
Yes, sir.
রাকিন আফতাহি, ফৌজিয়া আদিবা, ফারহান শারিয়ার,
Sir, Fauzi
Hello,
Adil
present, sir.
আছে স্যার, ওর নেটে মনে হয় প্রবলেম।